All right, welcome here. I wanted to talk a little bit about section 8.1 and just work out a couple of examples stolen from the WAMAP question. So here it says find the area in the left tail of a chi-squared distribution from the point where we have chi-squared equals 44.5 with 49 degrees of freedom. And I've been kind of harping on you to draw a picture. So the chi-squared distribution isn't one that I necessarily know super well, but it goes something like this. And we'll have a test statistic here of 44.5. I don't know where that is. I'm just kind of making it all up. And we're looking for the area in the left tail. So that's all of this. Now, we really let Excel do most of the work here. And so the important things here, our test statistic here, or our chi-squared value, is 44.5, and then our degrees of freedom is 49. And we're just given those in this case. So then to figure out the area, we'll use the chi-squared or chi-squared distribution. And since we want a left tail here, we just use the chi-squared distribution. It asks us for our x, that's our test statistic. I'm going to go ahead and type these in, 44.5. Our degrees of freedom, 49. And then we do true if we want the area up to and including that. And just copying and pasting here so you can see. Usually we round these to 4 decimal places, so 34408. And so this would be our answer here. Now, if we're looking for the area in the right tail of a chi-squared distribution from the point where we have chi-squared equals 23.3 with 49 degrees of freedom. Wow, I didn't choose ones with very much variance here. Sorry about that. So with the picture on this one, again, our chi-squared distribution is kind of weird. 23.3, let's just put it here. Okay, or not. Anyway, and we'd be looking for the area to the right. That's this one. And so again, gathering the important information we have. Our test stat is 23.3, or our chi-squared. Kind of hard to put a chi-squared in here. The degrees of freedom is 49. You might not always be given the degrees of freedom. So then our area, which is kind of like our p-value here. Again, with this one, we're doing a chi-squared distribution, and we're looking for a right tail. We actually have a right tail function, just like we did with the t-distribution. Oops. I'll type these in so that it shows up better in the work. 23.3 and 49. And there we have it. So obviously, my picture, not so great. As far as like this doesn't look like it's almost 0.9. Now, if this one we rounded to 4 decimal places because it's a probability, it'd be 993, and that would be our answer there. So there's a couple of the more simple ones to start, and if I click over to this page, I've got a bit more of one. A plant manager is concerned about her equipment may need recalibrating. It seems the actual weight of the 20 ounces of cereal boxes it fills has been fluctuating. The equipment needs to be recalibrated if the standard deviation exceeds 0.4 ounces. In order to determine if the machine needs to be recalibrated, 65 randomly sampled cereal boxes, boxes of cereal, actually these are bows, from the next day's production were weighed. The standard deviation of the 65 boxes was 0.44. Use alpha equals 0.1, determine if the machine needs to be recalibrated. So, a couple of things here, just going through. We have 20-ounce cereal boxes, and this is a mean. So this is probably mu. Not actually important here, just information in there. The equipment needs to be recalibrated if the standard deviation exceeds 0.4. So this is sigma, and the exceeds helps us with the tail. 65 randomly selected boxes. This is our sample size. The standard deviation of the boxes was 0.44. alpha equals 0.1. And then you see here we have some stuff to fill in. This is sigma squared and this is sigma. So if I want sigma squared, I have to take 0.4 and square it. And this is the null hypothesis. And this would be that sigma squared, so I'll just do sigma and a square, is equal to 0.4 times 0.4, or, oops, I guess here equals 0.4 quantity squared is this. And really this should be the null hypothesis that sigma squared is equal to this, right? The alternate hypothesis we have sigma squared and, oops, it says the machine needs to be recalibrated. Where was it in here? If it exceeds 0.4. So this is going to be greater than, and then again it's the 0.4 squared. So this tells us we have a right-tailed test. And that's important for our picture. The degrees of freedom are a thing we're supposed to find here. It's 1 less than n. So I would just click on this and do -1. If you want to know what that looks like, it's really 65 minus 1 for the work there. This is kind of how we'd fill these in. I'll kind of take you to a problem and we can do that. Now the test statistic is what we need to find next. And it is equal to the degrees of freedom, which we have right here, times our, oops, this is supposed to be an S. Well, let's see. We want this guy squared. I'll go back and fix it. And then divided by our sigma squared. So this right here should be S. I have 2 sigmas there because it autofills. Again, this is our sample standard deviation. And doing the work in Excel here, you can see I'm not really generating a lot of extra stuff. Now, we would normally write our test statistic to 2 decimal places, and this just happens to be there already. If you want more, you can just kind of drag it over sometimes. This is probably where it terminates here. Anyway, so we're going to draw a little picture here for our p-value. This is a right-tailed test, and we have a test statistic of 77 point something. So way over here is our 77.44, and we're looking for the area to the right, because it's a right-tailed test. So if I'm looking to find the p-value, I can use a chi-squared distribution right-tail function, click on the test statistic, click on the degrees of freedom, and that is it. Not a lot else to do there, except for round it to 4 decimal places. So there it is, the p-value. And then we follow our regular process, right? If we are greater than alpha, we will reject the null hypothesis. No, excuse me. If we're less than alpha, we reject the null hypothesis. So here our p-value of 0.1207 is greater than this, so we click the greater. The test statistic leads us to this. So I'm going to just really quickly jump over to where I have this here. Never mind. 0.16 greater than 0.16. Our degrees of freedom was 1 less. We were 77.44. Our p-value 1207, which happens to be greater than alpha. If it's greater than alpha, we fail to reject the null hypothesis. And then the final conclusion, if we fail to reject, there is not enough evidence to see that this is greater than 0.4. These values are the claimed ones. Try to squeeze that in there. Ran a little long. Let me know if you have any questions.